I will just refresh quickly mainly the statistical part that we did yesterday, so that everyone is clear um, about the statistics that are involved. Right. Okay. So today, basically, what I am planning to do is to take you through this particular software, what we call Rev-Man. So it's very important that you install the software and do these activities with me, because otherwise you will not be able to understand what we are doing. And usually when we do these training programs, actually we have it over 2 days. This is a 2-day session that I'm trying to squeeze into 2 days, in the sense 2 full day sessions, right? So this is it's kind of difficult to me also to kind of squeeze everything together, especially for a group of beginners, and do it in 2 hours, like yesterday 1 hour and today 1 hour. So only way out of this will be if you sort of do this practically, and then you can again, even when this is finished, you can reach out to me and clarify whatever the doubts that you have. There is no problem, right? So what we will be doing today is we will be looking at the software Rev-Man. For those of you who have installed, we will do it practically together with me. But before going to the software, we will quickly go through what we just did yesterday about the meta-analysis, the statistical part, right? Now I told you the meta-analysis will give you a pooled weighted average. But one of the important things in meta-analysis is you need to decide the type of the model you are going to use. Now in statistics also we talk about different models, no, different tests, different names are there. Likewise, in meta-analysis also there are 2 different key models that are there. One we call the random effects model, the other one we call the fixed effect model. These 2 models are used to calculate the weighted average. So I will show you in the Rev-Man software, the average that you get if you are using a random effects model and the average that you get if you are using a fixed effect model are different from each other, right? So one of the key decisions for a person who is doing meta-analysis is to decide between these 2 models. And basically this is based on the presence of heterogeneity. So heterogeneity, as I said, is measured by the I-squared value, right? I-squared value, which is more suited, especially when the number of studies are small, right? I told you this forest plot gives 2 things. One thing, it will give you the percentage of I-square, right? Generally, if it is more than 60 to 70%, we consider that as a considerable heterogeneity. But you have to also look at the p-value for the I-square, right? If both are significant, let's say more than 70% and the p-value is also less than 0.05, then you can consider that as having a significant heterogeneity, right? If there is heterogeneity, that doesn't mean you cannot do a meta-analysis. There are few options you have available. We discussed those yesterday, right? Heterogeneity doesn't mean that you have to stop the analysis, right? Of course, one of the options that we discussed yesterday is you don't do a meta-analysis, you just stop at a systematic review. That is option number 1, right? This is where the expertise of the research team is important. The research team, that is why I said you need to have a set of experts in the area to decide, because the experts will then look at the research individual projects and see whether these individual projects have clinical heterogeneity that is contributing to the statistical heterogeneity. There may be variations in sample size, variation in population ages, or maybe whatever. So if the expert team feels these studies are too different from one another, then they can decide, okay, we are not going to pool, we are just going to do a systematic review, right? That is one of the options that is available, right? Now this I have already told you, right? I-squared value and the p-value. So that is the first option. So that is where the expert knowledge is important. Okay, expert decide. We are not going to pool. We are just going to do a systematic review. The second option is usually not advisable. You can ignore the heterogeneity and report the data as a fixed effect model. Fixed effect model is not suitable when there is considerable heterogeneity, right? It is the random effects model that is suitable if there is considerable heterogeneity, right? Okay. So if there is considerable statistical heterogeneity, then you can switch the model from a fixed effect to random effects model. Now remember, this heterogeneity is in relation to the outcome you are looking at. You cannot tell that this is not for all the outcomes. For example, when we are pooling data, the pooling of the fasting blood sugar. Let's say now today we are pooling data from the effect of zinc on diabetes. We have two sets of data. We have fasting blood sugar, we have HbA1c, right? So when you pool the data for fasting blood sugar, I-squared value may be high, so that you may have to use a random effects model. But when you pool the data for HbA1c, I-squared value may be not significant. Then you can use a fixed effect model, right? So the heterogeneity can vary from outcome to outcome. That you have to keep in mind. For each and every outcome, you have to look at the I-squared value. Then the final option is there are advanced statistical methods where you can further explore the heterogeneity, and that is called meta-regression. Meta-regression is like a regression analysis. Of course, you can't do that in the meta-regression cannot be done in Rev-Man software. You will need a advanced meta-analysis software for that, or advanced statistical software like SAS or Stata, right? Another option is to explore the heterogeneity, what you call a subgroup analysis. I already described that yesterday. A subgroup analysis is where, let's say now here you have pooled data. I will go back to the forest plot. Now here there are studies that are looking at different doses of zinc. Let's say there is a set of studies where you have used 20 milligrams of zinc. There is another set of studies where they have used 40 milligrams of zinc. So you can see, okay, let's now remove the 20 milligram ones and let's see whether the higher dose is effective, the 40 milligram ones. Maybe that will remove the heterogeneity, right? Okay. So that is also something that you can do, right? So these are the different options you have when you are planning your analysis. So this is where the expert knowledge is required, and this is where sometimes it is good to have on board somebody with statistical knowledge on deciding the different model or the options that you can take, right? So that is where the complexity comes. Now in this study, we have decided I-squared is high. It is significant. So what we have done in this is to convert this into a random effects analysis. We have still pooled the data. We have not done a subgroup analysis, but we have reported this using a random effects model. So this is acceptable. Only thing is you have to say that in your article, this is what we did, right? Of course, sometimes we have seen reviewers will come up with comments saying I-squared value is high. Yes, you have taken that as a limitation, true. But what else can you do? Can you do a subgroup analysis? Can you do a meta-regression? Sometimes the reviewers will request. So then, of course, we will have to amend the article depending on the reviewers. So we have had instances where they have said, in addition to the main data, why don't you perform a subgroup analysis and put it as a supplementary file, right? So that we have had to do, right? So sometimes, although you report, you have to change in line with the reviewer comments, right? So the simple thing at your level to remember is, in meta-analysis, there are two important models. You have a fixed effect model, which is ideal when there is no heterogeneity. You have a random effects model, which is more suitable when there is significant heterogeneity. If you remember that for the time being, you will be okay. When you do meta-analysis as you go along, you will get further exposed to the different other methods and you will understand further what I am saying. But for the moment, this will be enough for you, right? Just keep that in mind. Publication bias also we went through. I checked the Rev-Man software. Unfortunately, there is no method for you to calculate the EGAS test. So that will require different software. So in the Rev-Man software, it is basically the visual inspection. You look at the funnel plot and it should be symmetrically distributed, where you symmetrically distributed between either side of this line. The main and nicely distributed in this triangle, where many studies are clustered at the bottom. The studies that are having the lower sample size, studies having a higher sample size are clustered at the top. So it is a visual inspection. So this particular diagram then will have to go in your article. Most of the time these will go as supplementary files. Otherwise you will have many diagrams. No? The forest plot will be one diagram. Funnel plots will be one diagram, so there will be too many diagrams. So sometimes we see that these particular ones, they are put as supplementary files where they publish only online. Now this is not a good distribution, right? Right. Forest plots, yeah, we already have gone through this. We will now open the Rev-Man software and I hope you received the articles I sent yesterday. So I will be basing the Rev-Man software activities based on these articles that I sent, right? So what we are doing is, I have taken from this meta-analysis, I have taken about 3 or 4 studies, 3 studies to be precise, and I have given you 2 outcomes. Extract the data for fasting blood sugar, extract the data for HbA1c, right? For both the intervention group and for the comparator group. I have selected 3 articles so that there will be confusion. If anybody has gone through the articles, obviously you will have 101 questions now, right? Because I have selected on purpose. Some of these research projects have 3 groups. Some of these research projects have 2 groups. Some of these research projects have multivitamins. Some of these research projects have 2 time points where they look at in 2 months what is the outcome, 4 months what is the outcome. So there should be lots of confusion for you. What data am I going to extract? Am I going to extract fasting blood sugar at 3 months, 2 months? Am I going to extract fasting blood sugar at 4 months? Now you will see, you will understand these are the practical questions that the expert team needs to answer. Now you will appreciate the need for a team of experts when doing a proper meta-analysis, right? I have extracted the data into the table. My data extraction may not be accurate. That is another thing. I told you the importance of dual extraction, where 2 people independently do this, right? Because I did not double check or verify these. I may have extracted the data from the placebo group into the zinc group, a zinc group into the placebo groups, right? So there may be errors. So you'd see the importance of extracting data by 2 people, right? Then there's a lesser chance of making errors during data extraction, right? So that you have to keep in mind. Now, before looking at this data, let's go to these articles, right? Let's go to Rev-Man software and also keep the articles also open, right? First of all, let's just launch the Rev-Man software and I will take you through the initial interfaces of the Rev-Man software. If you do these activities with me, it will be easier for you to understand, right? Let me open Rev-Man and share the screen. Okay, I hope you can see the Rev-Man, the software that I have opened, right? So this is the initial screen that you should be seeing unless you are using a different version of Rev-Man. But this is the latest version to my knowledge. There is no other version. This is the initial screen that you see, right? So you have the options here, either to open a old file that you have done a review, or you can select. Now here I have clicked to open file, but let's go back. right? You can select to start, you can select new. We are going to do a new project now. So then it gets you to this particular screen, right? So you can click next, follow this with me. So there are different types of reviews that now here keep in mind, the Rev-Man software have been designed by the Cochrane collaboration to write review articles for Cochrane, right? So you will see this is following the Cochrane format, right? Okay. But that doesn't mean we cannot perform analysis in this software. You can build forest plots and you can cut and paste the images. You can export those as image files, which you can incorporate into your research article, right? But if you want, you can write the full article. I will show you in the Rev-Man software itself, right? So there are different types of reviews that you can be selected. Intervention reviews, diagnostic method reviews, methodology reviews, so different kinds. Now what we are going to do now is what we call the intervention review. We are going to give zinc, diabetes. So we are going to select that. Click next. It will ask you, it will customize the title for you as well. If you want, you can say, okay, intervention is zinc, health problem is diabetes mellitus. This is the article title it's asking. Why it is asking article title? It is because this is thinking about writing a full Cochrane article. That's fine, right? So don't have to worry. You can select this also, where you can type in your own article. Now I have typed in the format here. There are several formats available. Zinc versus placebo, metformin versus glibenclamide for diabetes, for example. So you can customize the title depending on what you want, right? What are we going to do? We are not going to write a review protocol. We are going to write a full review. So select that. And when you click finish, your review file is generated. This will be the output that you should be getting. So you can see on the main window here, there is a right hand window where you can navigate between the different sections of the article if you are writing the article here. But on the main window, you can see these different subsections. So you should be seeing me going down. So there are many subsections. This is in the format of an article. So in the initial part, you have the title, what we have put. You have the list of authors. You can write the authors. You can input their names and the affiliations and so on. So if you go to add author, you can add authors. And if you double click here, you can enter the details of the authors, right? So what happens when you double click is it opens a new window here, right? So you can enter the details of the authors, right? You can click cancel to come back to the main page, right? So a lot of even the abstract can be entered here, right? The background of, so this is in the format of the Cochrane collaboration, right? Okay. So you can enter the data, right? So some of these are not relevant if you are performing a review and only wanting the forest plots and the funnel plots, the statistical part, right? If you are writing a full article here, then of course these sections you can go on filling, right? Now, okay. And the other good thing about this is you can change. This is not a very rigid software. So that is another thing that I like about this. A very flexible software. Although we initially gave the title, that doesn't mean you cannot change. Now here I can easily change type 2 diabetes mellitus, right? Zinc versus let's say placebo, right? So easily it is a very flexible software in that sense, right? So that is another good plus point about the Rev-Man software, right? Now, what we want to do now here is the statistical analysis, right? The first step in statistical analysis is to add all the studies. Now, if you click on here, can you see this? There is a particular on the left hand menu, there is an area called studies and references. Studies and references. Can you see that? Yes, good. So when you click on that, you should be getting a screen like this, where the main screen has now moved down, right? This is not a new screen. It has just come down from the earlier one to this particular section because we use the left menu to navigate. Here you need to add the studies that you are planning to include in the meta-analysis. What do you mean by including the studies? You will see. right? Those of you have got here, click add study, right? Then it is asking for the study ID. Usually studies are identified by the name of the first author. That is what we will use. No? So let's say I will name the study Ranasinghe. Right, okay. And then, so are we, then it will ask what type of data you are including. Now, this is all part of the Cochrane collaboration. Sometimes we include only published data. Sometimes you will see, now I will tell you examples. Now the 3 articles I have selected, there is missing data, right? So when their data is missing, you can contact the authors and ask for unpublished data. So then if that is the case for this article, you have to select publish, and that doesn't make much of a difference. This is coming when you are writing the article in the Cochrane format. That doesn't make a difference for the meta-analysis part, right? So let's just say we are going to only talk about published data. Then it will ask the year. Let's say the study was published in 2020. Then when you click next, okay, this you can click next, do nothing. Of course, you can select this, then immediately you can add another study. If you select nothing and finish, the included study comes here. Now, can you see under included studies, the name that I have included has come here. Of course, I have typed the wrong spellings. That doesn't matter. You can easily go and correct it, right? You can easily go and correct it, and it collects itself, right? So the included study comes here, right? Now your exercise now, those of all of you would have got this. Open the 3 PDF files that I have sent you and add those 3 studies, right? I will also do the same. Open the 3 PDF file, okay, one by one, add those studies here. We will include the studies by the name of the first author. Doesn't matter if you make spelling mistake. This is just a learning exercise, right? But I just want you to show because then we will use this particular one in the next step when we are adding data. So these identifiers, you should make sure you use identifiers that can identify each study by their names, so that you know what are the studies you are referring to when entering data. Otherwise, you will make errors when entering the data. Quickly enter the studies. Right? You can cut and paste also. That's that option is there. You can quickly cut and paste. That's how I'm doing. So that can also be done. So I have included study number 1. You go to add study again to include study number 2, right? I hope you are following what I'm saying, and you are entering the studies. Finished. So 2 studies. So you can see now I have entered 2 studies. Let's add the third one as well. Now here is the problem. There are 2 studies by the same author. How do you name these? You can still use the same name, provided, now here, provided the article year is different, then you can identify, no, right? Now here, this particular earlier study was by Favid, but it was in 2005. Here, from the same author, there is another study. However, this study is in 2011. So there is no problem. But sometimes you see from the same author, there are 2 studies from the same year. So how do you identify these studies? Then you remove the et al, and then this will come. Okay, wait. Then you have to name these studies. Let's say this is 2005. Then you have to put this as A, the other one as B. You have to know what is A and B, right? So that is, this is the name that will appear in the forest plot, right? This name, what you have put here. Now I will go back again to the forest plot and I will show you. go back again to a minute. I'm switching between screens. I hope you are following me. So if you go back to the forest plot, you can see these names that I have given here earlier. This is the name that you give there. So that is the name. Those are the names that will appear here. So these have to tally with your reference list. If somebody wants to find out this particular study and relook at the data, obviously the name you have given here should be, they should be able to find from your reference list, right? So you have to give an identifier that makes it possible for people looking at the forest plot to identify the study. So you have to make it unique so that people can identify by looking at the forest plot. And then when you name A and B, sometimes what we do is at the legend, the bottom of the forest plot, we say what is A and what is B, so that people can easily find that from the reference list, right? So sometimes this happens when the same author has two publications that are in the same year. If the same author like this has two publications in different years, then there is no problem, right? Okay. So we have included the art studies here. Now we are getting on to adding data, right? Now let's go back to my PowerPoint, and now I hope you were able to generate the same table that I have done by extracting data. Right, I will share the PowerPoint again. Right, you should be seeing the PowerPoint now. Were you able to extract the data for these values? Article 1. So what I have given here is the sample size in the zinc treatment group, in the placebo group, and then I have given the mean values pre-intervention, mean values post-intervention, and then the p-value of the difference, right? Same here for the placebo group. Same here for the placebo group. And then here I have manually calculated the difference by my deducting the post value from the p value. So here pre value, here it is minus 16.1, here it is 1.9, post minus pre. Now you will have a question, why haven't I put the standard deviation? Why haven't I put the standard deviation? Is the standard deviation of the, now here the standard deviation is for the pre-value. Here the standard deviation was for the post value. What about the standard deviation of the difference? Don't we need it? I will tell you in a short while when we look at Rev-Man. All of you, were you able to get this data? Do you have a similar sheet like this?
No, sir. Second line, the article 2 and 3 was different. We got, but first article okay, because of, there are
yes.
different size groups.
Correct. Yeah. So let's base our
first one. Okay.
Yeah. Second article, third article, I purposely selected ones that there are confusion because there are some learning points from that, right? So let's focus on the first one for the time being and start entering the data into Rev-Man for the first article, right? Okay. Yes, I understand there is a confusion with the p-value. I will clear that in a little while. Okay, now let's go to Rev-Man again and see how we can add the data for the first article. Let's only focus on fasting blood sugar. Now we have already added the studies. Now we are going to add the data. Here you see on the left-hand menu, there is something called data and analysis. Double click on that. You should be getting here. You should be getting here, right? Click add comparison, right? Add comparison. So you can say, now here here the comparison means what are you comparing? So here we are comparing zinc versus placebo because some meta-analysis, there are multiple comparisons. Like for example, you have many arms in clinical trials, metformin versus the glibenclamide, metformin versus let's say another sulfonylurea. So there are many arms in some studies. So here the main comparison we are looking at is zinc versus placebo. So you add, so here the thing is you can add multiple outcomes. So here in my software, there is a small error. Otherwise, because I'm using Apple, I suppose, otherwise what I have entered should come here. Right, but here I will have to manually enter again, but you should not be having problems. What I entered there should actually come here as the title. It doesn't come in my one. There is some problem with the software, right? Don't worry about that. You should be getting something like this. And under each comparison, you can add the outcomes. Now you will see zinc versus placebo. We are talking about two outcomes: fasting blood sugar, HbA1c. So those are the outcomes. Comparison means what we are comparing. Outcomes are what we are looking at. So here we are looking, so you can, so were you able to add the comparison?